Alright, in this video I'm going to continue with problem 5D, which is a chain rule, but the inside function is a quotient, so I'm going to need a quotient rule within a chain rule. So g prime of t is equal to, I'm going to bring down the 9, leave the inside alone, reduce the 9 to an 8, and that's taking the derivative of the outside, leaving the inside alone. Now we need the derivative of the inside, and that's a quotient rule, so that's low d high, but the derivative of the numerator is just 1, minus high d low, where the derivative of the denominator is 2, and that's over 2t plus 1 quantity squared. Simplifying that numerator, it's going to be 2t plus 1 minus 2t plus 4, and that leaves me with just a 5 in the numerator there. So that's pretty much done. If you notice that I do have 2t plus 1 in both denominators, one is to the 8th power, one is to the 2nd power, and then I have the 5 and the 9 that can be multiplied by each other. So a simple final simplification here would be 5 times 9 is 45, then t minus 2 to the 8th power, and then my denominator would be 2t plus 1 to the 10th power, and that should do it. Okay, for part E, we have a triple chain rule here where the inside most is tan, the middle is cosine, the outside is sine. So I'm going to take the derivative of the outside, which is sine. The derivative of sine we know is cosine, and we leave its inside alone. So it's the derivative of sine, which is cosine, times cosine of tan x. Now we're going to have to take the derivative of the middle function, which is cosine, and the derivative of cosine is negative sine, and we leave its inside alone, so that becomes negative sine of tangent of x, and then we need the derivative of tangent of x, which is secant square of x. So if I was going to simplify, bring out the negative to the front, and that should do it. That's the answer for that problem. Alright, we're going to go on to number 6. Number 6 just asks to find the derivative of h of x, which is equal to f of g of x. So it's a very simple chain rule in abstract terms. We don't know what f or g are, but we take the derivative of the outside function, which is f of x, and leave the inside alone, which is g of x, and multiply that times the derivative of the inside function, and that's going to give us g prime of x. Okay, and that should be not a big deal there, but we need that for the problems below. In problem 7 you have some tables of f values, g values, f prime values, and g prime values, where the x values are over on the left hand column. And we're looking to find h of x. What's h prime of 1 if h of x is f of g of x? And that's exactly the formula that we have above. So if we're looking for h prime of 1, then we need f prime of g of 1 times g prime of 1. Well, g of 1 is 2, so we need f prime of 2, and f prime of 2 is 5. Then g prime of 1 is 6, so we need 5 times 6, which is 30. Alright, for part B, we need capital H of x. We need capital H prime of 1, where capital H of x is g of f of x. And so that is just g prime of f of x times f prime of x. And so capital H prime of 1 is g prime of f of 1 times f prime of 1. And we go to our table, and we see that f of 1 is 3. So we need g prime of 3, which is 9. So that tells me that g prime of f of 1 is 9, and f prime of 1 is 4, and so we end up with 9 times 4, which is 36. Okay, and so that brings us through the last of that problem there.